4 different talks on REST and microservices. All very good speakers. We also have a talk on resolvers and getting knowledge from that. We have talk on dealing with bundles. Stick around in this session. It's going to be quite interesting. Before we get on to Graham's presentation, I want to make a quick announcement. OSGi Alliance recently released the early drafts, and we do that frequently. They're publicly available of release 7 of, I don't know if you can read this, but talk to me about anything related to OSGi and OSGi Alliance.
We have downloaded this already. The draft version R7, 1200 pages.
Say that again?
Yeah, I mean, we downloaded this already.
Oh, you already, yeah, but some of them are newer, so that's why they didn't attend the sessions here yesterday, so I just wanted to quickly repeat that. I appreciate your patience on that. So just wanted to point out that the early release for 7, for core, for compendium, and we have the residential release 6 supplement. If you want the URLs, just take a picture or just go to the main page and you can navigate there. Thanks for the patience and the quick announcement. Let's get on with today's presentation by Graham Charters. I've known him for a while in OSGi and other places. He's a big contributor to the enterprise expert group, and I was his lead there. He's the senior member of technicals. I need to get that right. Senior technical staff member. I always swap it. And works on WebSphere application server. He's the lead for Liberty Repository and OSGi programming model.
Yep.
Did I get that right?
Yep.
And a frequent speaker at these conferences is going to talk about microservices and how it relates to the maturity model. The modularity maturity model that we talked about several years ago. So over to you, Graham.
Thank you, Anish. So I've got rather a lot of slides. I usually only try and do a small number, but I wanted to pack quite a lot in because I've got quite a few messages. So hopefully it'll all fit in time. I've got my little clock going there, so we'll see how it goes. So what I want to do, there are kind of 4 main parts to the talk. One is kind of just introducing some concepts. Not everyone will have the same understanding of these concepts. My understanding might be wrong, or different, in which case this is my kind of level setting part. So I'll talk a little bit about modularity, a bit about microservices, and a bit about OSGi. I'll then use, as Anish said, the Modularity Maturity Model to kind of compare the capabilities of OSGi and the capabilities espoused by those talking about microservices. I'll talk a little bit about some of the challenges of microservices and why maybe caution's appropriate in terms of going towards or moving towards microservices. And then I'll finally summarize with how maybe OSGi has a role to play in helping smoothing getting to microservices. And then following on from this talk, we've got a bunch of talks that actually go into some details about how you can use OSGi to implement microservices. So, level setting, modularity. What is modularity? So, in essence, we use terms like module and component to refer to things that exhibit modularity. Modularity is the ability to look at something, examine it, understand what capabilities it provides to the rest of your environment, and ideally understand what capabilities it requires from the rest of the environment. So once you have that kind of information, you can reason about that component or that module and understand how to plug it into some system. Anything else to do with that is implementation detail, and you should be able to change the internals of that module or that component as much as you like, and as long as you don't break the syntax and semantics of the externals, then it's plug replaceable. So that's in essence what modularity is. So what are microservices? So there's probably quite a bit more variability in terms of people's definitions of microservices. So what I wanted to do is, rather than try and come up with my own set of definitions, I'll reuse some of the characteristics or the characteristics that were defined in an article back in March 2014 by James Lewis and Martin Fowler. So they listed out some of the kind of common characteristics they see for microservices. So the first one is componentization via services. So this is probably a bit of a no-brainer, and probably everybody agrees on this. So this is saying that The components of my system are essentially services. They're the microservices. There's some implementation sat behind those services, but that's essentially what microservices is all about. It's about breaking up systems into sets of remotely addressable services. Organized around business capabilities. This one I think is really interesting. This one is, rather than what we've traditionally done in the industry, which is kind of slice things horizontally, so talk about data and business and presentation, it's saying let's take a vertical slice through things and organize your capabilities, organize your service components around a business capability. But it goes beyond just the code. It talks about organizational things. So there's I forget whose law it was, but back in even 1967, there was an observation that your architecture of your system tends to be a reflection of how you're organized as a development organization. So what this says is create, essentially, think about Spotify squads and so on, create squads that are responsible for those services. So this is what I like to refer to as kind of organizational modularity. Products, not projects. We have this kind of failing in the industry, I think, in the IT organizations. They'll start a new project, they'll develop the thing, and then they'll say, right, we've done it, it's live now, we can go and disband that team and they'll go and work on something else. You need to think about microservices as products, and the team that's responsible for that microservice is responsible for the entire life cycle of that product. So it goes beyond development, it goes into production, it goes into service and support of that thing. Smart endpoints and dumb pipes. This one is saying, there seems to be this kind of, and it's not a hard and fast rule, but this view that in the the traditional SOA world, there was a focus on being able to do things like transformation and routing and mediation between services in your SOA, and there was a focus on things called ESBs, or enterprise service buses, that did this kind of work. In the microservices world, there's more of a focus on actually doing those kinds of mediations and routings actually at the client side. So it's the responsibility of the person calling the microservice to make that call good. You're not relying on some intermediate party to transform it and route it for you. Decentralization of governance. This is, again, another organizational thing. When I talk to a lot of customers, their IT shops are quite hierarchical, so they'll have a core architecting that's for the rest of the organization. This is actually saying, don't go that way. Empower your teams, empower the individual pods to actually decide on their own standards and what technologies they're going to use for the microservices. Decentralization of data management, that's similar to this one, but it's all about the data. The squad, the microservice owns the data. Infrastructure automation, so when you think about you're moving from a single monolithic, potentially, application to deploying maybe tens or hundreds of microservices, you've suddenly made your deployment a lot harder. So you better automate the hell out of that, or you're going to sink under the weight of it. Design for failure. So when you've been doing local calls within a single application that's been deployed, everything's fine. You know the thing's going to be there that you're calling because it's in the same process. It's part of the same unit that you've just deployed. When you go to microservices, the thing you're calling might not be there. There might be a network failure. They might have tried to do some upgrade and actually screwed it up for some reason, and the service isn't available. So you need to make sure that those problems don't cascade throughout your entire microservice application and take the whole thing down. And then design. This is, I'm not so interested in this one. This one is just saying that you need to be able to, it's kind of applying agile to microservices. You need to be able to evolve the thing over time. Don't think that you've got your microservice right and that's it. You need to be able to change it over time, change your system over time. There may be microservices you create that are kind of more situational microservices just for maybe some campaign that your company's doing, and you're going to throw it away after a month or two. All right, so actually quite a few of these correspond to modularity. So I just want to quickly go through which of those I think show characteristics of modularity. Well, componentization via services, that's hopefully a fairly obvious one. Organized around business capabilities. I think this is about modularity because what you're doing, whenever you see things talking about modularity, and indeed it's in this paper, there's talk about high cohesion and loose coupling. And this is about doing that around business capabilities. If you put your business capability around, wrap up a particular business capability within a microservice, you're creating something that is hopefully highly cohesive and loosely coupled with respect to the other microservices. But also, this is about organizational modularity. It's about creating a team that most of the communications that need to happen within that team. And only when people need to integrate with your microservice or you need to integrate with other people's microservices do you need to communicate with those other teams. Smart endpoints, dumb pipes. Again, this is about cohesion. This is about bringing what might have traditionally been done out in the network in some ESB into your microservice. So you're responsible for all of that. You're creating something that's more cohesive. Again, decentralized governance and decentralized data management. Again, you're bringing things into the organization. It's about organizational modularity and it's about data modularity. And then finally, designing for failure. This is a characteristic of modularity when your modules have a dynamic life cycle. So when things can come and go in your environment, you need to be able to react to those changes. All right, so that's the level set, hopefully, on microservice characteristics. This is going to be the quickest introduction to OSGi, hopefully, you've ever seen, but hopefully it'll make sense. So is everybody familiar with OSGi? Let me ask it the other way around. Is anybody not particularly familiar with OSGi? One. Okay, this one's for you. This is your slide. So OSGi, what OSGi does is provides a module system for Java. It takes the concept of a jar and adds additional metadata to it, additional information to it that turns it into a module, essentially. So it describes things that it provides, the capabilities it provides, and the capabilities it requires from other modules in the system. So that's what OSGi refers to as a bundle. Bundles can communicate via services, so it has a kind of local SOA model. You can publish services to a service registry. You can go and find and use services from the service registry. Those services are actually, you can think of them as essentially just instances, objects registered in the service registry. You go and get that object, you can call that object. So this gives you a nice decoupling between the bundles because you're not having to use some kind of factory that's provided by the object over the other side. That thing's just registering a service and then you're going and using that service. And then finally, OSGi bundles can have a dynamic life cycle. So that's what this little circular thing's trying to indicate. So they can come and go in the system. You might uninstall this one, which means that service will be unregistered. This thing will be notified that that service is no longer available, so it stopped using it. It may need to behave in a different way because the service isn't there. But then when a new bundle comes back that provides that service, it can then start using that service. Okay, that's OSGi. Who'd think there'd be hundreds of pages just to describe that? All right, so what I want to do now is just compare compare microservices, understand microservices in terms of the modularity capabilities they provide and how that relates to OSGi. So at the OSGi community event in 2011, which is the last one we did on our own before we twinned up with EclipseCon, somebody presented a proposal for a modularity maturity model. So this was based on observations with customers, understanding how they were using or adopting OSGi and seeing how they started out thinking about modularity and over time evolved their thinking and got, I guess, more advanced but also got more value out of the technology as they went. And it defined 6 levels. So just briefly, the 6 levels were ad hoc. So this basically says they're not doing anything to do with modularity. They're not using any technologies to do modularity. They're just writing their code and building it and kind of hoping it works. Modules. This is where they start thinking, breaking the system up into modules and thinking about them in terms of modules, but they're not really doing modularity. So you can think of technologies that provide this kind of capability, Maven, for example. So Maven has the concept of modules or Maven artifacts that you depend on. They're described in terms of Maven coordinates, so group ID, artifact ID, and version, so you can go and find that thing. But so you've got a formal identity, but you're decoupled from the artifact. It might, you know what an identity is in Maven terms, but it could be a jar, it could be a war, it could be something else that's actually behind the scenes. Modularity, this is where you start describing the contract, so describing the capabilities the thing provides and the capabilities the thing requires. So you start being able to depend on contracts and rather than depending on the identity. So you can actually have a different artifact behind the scenes that provides those contracts over time. Loose coupling, this is where you actually break the coupling up between things. So in this case, you're depending on a very particular capability. You might be able to use something like OSGi semantic version to make that dependency a bit more flexible. So a number of different things can provide that over time within some definition of compatibility. Also, services give you loose coupling because different people can provide the same service over time, or different assets can provide the same service over time. Devolution, this is one that is kind of less common. The last two are less common. So this is the idea that you decouple from ownership. So rather than you being responsible for all the artifacts, you start having teams and collaborating around repositories of artifacts, and maybe provisioning your system from repositories. So you just start off with a seed, an essence of what your application is, and go and pull everything in from repositories at deploy time. And then finally, dynamism. This is the ability to react to changes and to cope with things being removed and added to the system over time, so you can do hot deployment. So so let's think about what Lewis and Fowler said in terms of microservice and where some of those capabilities fit. So loose coupling, well, microservices are all about componentization via services. There's a service, as long as it implements the same API, you can use different service implementations. So you've got some form of loose coupling there. Organized around business capabilities. This is a bit of a weaker fit here, but this is kind of the idea that you've got teams that are responsible for those things. You've got collaboration around the creation of the entire system and so on. And then dynamism. Well, they say explicitly designed for failure, because those services when you think about a microservice application, the services can come and go. You need to be able to cope with those. And then just filling in some of the gaps which they don't explicitly mention, probably because they just think they're a given. The module concept, when you're building your microservice, there's going to be some kind of identity associated with that. That might be Maven coordinates, so you build your microservice using Maven, and it's going to have a group ID, artifact ID, and version number. So there is some kind of identity. You can refer to that as it goes through your DevOps pipeline. And then modularity, well, you're doing microservices, you're perhaps typically doing REST APIs. You're probably going to be documenting those things using something like Swagger. So I've just described how microservices addresses all those stacks, and that's what the Modularity Maturity Model was describing, how OSGi addressed all those stacks and how people were adopting OSGi and working their way up the maturity model. So does that mean we don't need OSGi? Well, hopefully not, otherwise my talk's done. But so the answer is microservices. What's the question? I wondered where we were on the Gartner technology. What's it called? The technology adoption curve? I can't remember. Height. Is it height curve?
It's informally referred as that.
Yeah. Yeah. So there are a few key points. So Gartner kind of classify technologies into points on this curve. So things that you've probably never heard of are sat around here, and they're just kind of bubbling away, and then eventually people learn about them and they start working their way up the curve. I'll talk about this one last. When technologies have kind of reached a certain age, they tend to have gone down into this trough of disillusionment at some point, which is where people have thought it was great, tried it, and there have been quite a few failures along the way, and people go, oh, you don't want to do that. It was clearly the wrong answer. And then eventually we learn about the technology and how to apply it, and we kind of come out of the slope of enlightenment and into the plateau of productivity where we know actually how to do it. Gartner says we're around here somewhere. I couldn't find a chart that actually said exactly where, but so we're currently with microservices at the peak of inflated expectations. So what that means is there are a few examples where people have been really successful with the technology, and they're kind of blazing the trail and showing the industry this is a great thing to do. But the technology isn't there yet necessarily. So There's kind of not a maturity or a shaking out of the industry. There's lots of people trying to provide technologies to do this kind of thing, but they're doing it maybe in slightly different ways, and there's not an understanding necessarily across the industry about exactly what is right. And also there's not an understanding in the industry about when it's appropriate to do it and when it's not. So when you're up here, you tend to actually over-apply it. You try and do X, in this case microservices, when perhaps it's not appropriate to do it. And there are a bunch of articles that have been written about this kind of cautioning. Maybe you don't want to go straight to microservices. So this is what Fowler talks about in one of his articles, where basically says the successful ones have been where people have started with a monolith that was too big and they've broken it up. So maybe it's been successful because they've understood what it was that they created and why it's wrong, so they know how it should be in the future. Most of the unsuccessful ones are where people have actually thought, I'm going to do this new thing and I'm going to start out with microservices, and maybe they've been, I'm hypothesizing here that maybe they've been unsuccessful because it was new and they didn't understand what the architecture should have been like, and so they've created maybe the wrong microservices or they've bitten off too much. Simon Brown makes the observation that, yeah, microservices are a good idea, but if you can't, the kind of design or architecture is still hard. It's not that we didn't know how to do architecture and design and we were just stupid when we created monoliths. It's a hard problem to do. I particularly like this one. So I've talked to a lot of customers about OSGi and about modularizing their systems. Quite a few customers I've spoken to, their starting point has been to take what they've got and just turn every jar or whatever into an OSGi bundle and say they're done. And I kind of make the observation, well, that's fine, but all you've done is documented your spaghetti, or in this case, documented your poop. So what the observation here is, if you build poop as a monolith, there's a pretty good chance you're going to build poop as microservices. There's also associated cost along with microservices. So Fowler talks about the various benefits of microservices, but if you move to microservices, everything's distributed. So you need to be able to cope with the fact that there's a network involved, there's latency, there's failure, and so on. You need to cope with eventual consistency. So you're no longer able, even if you're no longer able to do transactions across your database to update, or across your database and your messaging and so on, to update multiple things in a transactional way. Each microservice owns its own data. So if you're doing a piece of work that requires an update in this microservice and an update in this microservice, there's a time when those things are inconsistent, and you need to be able to cope with that in your system. And then there's the operational complexity. So as I said before, previously you were deploying one thing, now you're deploying tens or even hundreds of things. So have I just said we shouldn't be doing microservices? Well, hopefully not, because I think OSGi and microservices, there's a benefit. That's kind of the point of the talk. So what if we could actually, if we're thinking of going to microservices, what if we could actually kind of look before we leap, or get an understanding or an appreciation, or actually kind of work our way towards microservices in some way? So there's been a bunch of articles written about this. So Martin Fowler, in the same one where he talked about the kind of patterns of failure and success, talked about monolith first. Now what he means there is actually creating some kind of modular monolith as a kind of evolution towards microservices. So rather than try and go here, and it's kind of there be dragons along the way, and trying to get to microservices straight away, create yourself a modular monolith, and then tease out the microservices over time, and eventually everything will become a microservice. And this kind of fits with patterns that we've seen for other technologies. And Simon Brown also talked about the modular monolith as a stepping stone. Basically, as he said, if you can't build a modular monolith, what makes you think you can do microservices? So basically, start out trying to create this modular monolith, and then eventually you'll know whether you think you're ready to do microservices. This one's interesting. So what is it that, so some people say that you can't do modular monoliths, it's a bad idea. Stefan was one example, actually writing in response on martinfowler.com to Martin Fowler's Modular First article, which he actually reviewed and fed back on. And he doesn't believe that that monolith first is a good idea because you're still probably going to create something that's entangled over time, because the whole point of microservices is they put boundaries up. They put hard-to-pass boundaries up between the microservices. So you're not going to decay over time, which is what typically happens and why we end up with monoliths. Fowler also talked about boundaries, again saying decay is less likely with microservices because you're putting, again, hard boundaries up in place. I like this. I'm a pictures person, so this is what Simon Brown said in his. So this is where you are today. Try and create this modular monolith here, and then eventually get to microservices. And try and, he talked about kind of techniques or approaches you might want to use to try and create this something in between, as he says. So what can we do in order to, let's assume the starting point is we've done a great job of creating monoliths, and we want to get to microservices. How can we get from there to the other end without having to go the whole hog all in one go? And so this, to my mind, raised a couple of questions. Again, Simon Brown goes into a little bit more detail. So these are what he describes as the characteristics for a modular monolith. So the usual modularity things like high cohesion, low coupling, but also talked about focused on business capabilities, et cetera, et cetera. And then there's a bunch of characteristics that you add when you get to the microservices world. So he talked about individually deployable, individually upgradable, individually scalable, heterogeneous, and so on. So two important questions. What is it that's going to help me create this and not have it decay over time? And what technology can I use that's going to get me as close as possible to microservices without actually incurring all the costs of microservices? Guess what the answer is? OSGi. So we saw OSGi enables you to build modules. You can create services, so you can start thinking about your system in terms of a kind of service-oriented architecture, and they have a dynamic life cycle. So what can we do with OSGi? So starting with your modular monolith, use OSGi to modularize your product. Break it down into OSGi bundles, collaborating via services and so on. So I think this isn't just about OSGi saying, oh, we know how to do it, we've been doing it for years, because I think OSGi has something to learn from the microservices world. Because what you should be doing also is thinking about changing your organization. So organizing your people and organizing your code around business capabilities. I think traditionally we haven't done that. The focus has been on reuse rather than the organizational aspect of creating the software. Also, modularize your data. So think about breaking your data up into business capabilities rather than just having, oh, I've got a database with everything in there. And if you do that, then you start, there's a better chance that when you eventually do get to microservices, you're going to be successful. There are a bunch of techniques that have been presented. I've done conference presentations talking about how to use OSGi to modularize existing things, bunch of patterns. They're equally applicable, I think, to my OSGi and microservices. So what can you do next? So you can start thinking about your modular monolith in terms of subsystems. So start defining collections of bundles. These are the things that provide a particular business capability, one business capability. So you're breaking it down along the lines of your business capabilities and along the lines of your organization. So perhaps one of your squads provides one of these to the system. You can then start, OSGi has subsystems as a technology that lets you do that. Other projects have similar kinds of capabilities. You could then turn those subsystems into application subsystems, which then put hard boundaries between each of the applications. You're still deploying them to the same server instance, but now you start not being able to share bundles, and you start thinking about how to do remote calls between those things. I say remote, they're still going to be they're not going to be leaving the system, leaving the box, but you're actually using the right semantics. It's all going to be passed by value rather than passed by reference. And then finally, you can split those things out and start deploying them separately. So you kind of got there. You're at the kind of microservices world, and you can split those out one by one. You don't have to do them all at once. There are probably additional things you need to do with your remoting, because now there's latency there, more latency than there was when you would plug to the same server and so on. And at this point, you're going to hell out of your deployment each time you spit out one of those microservices. So what does that mean? Well, if we go back to what Simon Brown described as the characteristics, I think actually what we've achieved is we've managed to move a few of those characteristics across into your modular monolith. Because what OSGi does is it enables things to be individually deployable, individually upgradable, and individually replaceable within a single server process. You don't have to go to microservices at that point to get those characteristics. And maybe organizationally you want to start doing that to know whether organizationally you're going to be able to do that when you get to microservices. Okay, so what technologies does OSGi have that enable you to build microservices? Well, we've got things like, we've got a bunch of approaches to doing remote services. There's remote service admin, where you essentially decorate your services with metadata, and then a remote service implementation can go and remote that service and also provide a proxy on the calling side. There's a bunch of JAX-RS implementations out there that work in OSGi, and there's also a spec going on around defining JAX-RS whiteboard as an approach to doing JAX-RS in a very OSGi-centric way. And I think Neil Bartlett's going to talk about that later. Okay, what other things are interesting? So I thought it might be interesting to take a look at what MicroProfile.io have defined as part. That's a group of people in the industry who kind of got together and defined a set of Java EE technologies that you might want to microservices. You can tell it's a fairly minimalist set at the moment. You couldn't build a particularly useful microservice out of just that because there's no access to any data there or anything like that. So that's the kind of meets min, and then you want to add things on top of that. What about OSGi? What are the equivalents? Well, we've got the ability to use JAX-RS in OSGi applications, and the JAX-RS whiteboard coming along. Declarative services is your component model for writing components and having those collaborate with other components in your bundles, and yeah, why not JSON-P? Going beyond that, if you think about microservices, I've got 5 minutes on there, something like that. One. Yeah, you took 2 of my minutes up. So. You took 2 of my minutes up, so I'm going to take them back. You think about, so there's a strong correlation between people doing microservices and people adopting the 12-factor application approach to building applications. One of those things is externalization of your configuration. So the ideal world is I build my microservice, and then I take that thing and it goes all the way through my DevOps pipeline. I test it, I do pre-production, and eventually it goes into production. And I don't have to do any surgery on that thing. I don't have to change anything inside there. So what they say is you should externalize all your configuration. So anything that's specific to the environment in which you're going to run that microservice needs to come along with it, not be part of it. And so we have config admin as a great technology for externalizing configuration outside microservice components. So just to summarize, I think microservices are an important approach to producing highly available applications. I think they are a step forward in the industry. But caution, they're not for free. The technology isn't as mature as it will be, obviously, but maybe not as mature as it needs to be. And there's also the costs associated with actually going to microservices around distribution and operational costs. Modular monoliths are seen by a number of people, myself included, as a nice stepping stone towards getting to microservices. And I think we, as a kind of the OSGi community, can learn from the microservices community in terms of how to build a modular monolith, which goes beyond just the code. It also takes on some of the organizational aspects. I think OSGi is great, or ideal, as I say, fit for building modular monoliths. And we have a bunch of standards that actually cover the core capabilities required for doing that. And there's going to be talks that follow on from this that go into that. So that's me done.
Any questions?
Do you have any experience in scaling modular monolith? Which means you mentioned you have different sites all over the world.
Yep.
You have modular monoliths. How do you scale them actually?
Well, it's kind of business as usual. So we scale. The key there is it's still a monolith. So you deploy it and you scale it in exactly the same way you have in the past. So you can think a monolith might be a traditional Java EE application that's got it runs somebody's business. It provides somebody's website, say, for example. So it's got all the capabilities for the website, all the business logic, all the data associated with it. And you scale that in the usual ways. You deploy that to some application server. You've got load balancing going across it. You've got session affinity and so on. So it's business as usual.
But you mentioned you only have few bundles that you have to scale it instead of the whole monolith?
Yep. So then actually it's still business as usual, but you typically try and make these things stateless and so on, so you just scale those horizontally again, just load balancing across them. They've typically got some REST API in front of them, so you're just doing HTTP requests across them. And because it's stateless, you can just go to any. Yep.
Question to the last point, what you mentioned here in the summary. What I don't get, honestly, is if we have OSGi, why we go this way of too far with the microservices? If it's the first class solution or the first class standard to make microservices,
yeah.
Why we don't just go with the OSGi way? I mean, the capabilities are there. Why with remoting services and all the stuff? So that confuses me a little bit.
Okay. So I think the way to think about it is OSGi provides a set of technologies for building applications. And those applications might be a monolith, they might be a microservice. They're good technologies for building both of those things. And microservices, let's assume you're going to use OSGi, that's the implementation technology. Microservices themselves go beyond an implementation technology. There's all sorts of aspects. It's a cultural thing about how you organize your organization to build those things. It's a change in how you think about those things operationally and so on.
Then, it's not your fault, but then I think then the naming of microservices should be something else.
Oh.
Because
yeah.
You just hit a nerve.
Yeah. So OSGi had the term microservices well before microservices did. It's just it wasn't as visible. Let me put it that way. So now people sometimes talk about nanoservices as being the OSGi services, and then micro is a bad term, I think, for microservices because they're not typically that micro. But yeah.
So let's do one more question, and we can have a hallway conversation if we need to.
Okay.
How good are OSGi services at dealing with the typical problems of first microservices like network going down or instances crashing? Is there any support for that, like network services where you can unregister such instances?
Yeah, so I guess your mileage may vary based on implementations, but remote service admin itself does have the concept of if a service is taken away, that fact is published throughout the network, and you unregister. What you do on this side is unregister the proxy. So this client, because OSGi is dynamic, you see the service going away on the client side. You know it's no longer available, so you don't need, you can't call it. So there is always a kind of gap there where this thing gets unregistered, but you haven't been notified yet. So you still need in your code to deal with the fact that it might not be available, and that there's kind of no way of getting around that kind of thing. You're just going to get service unavailable or whatever back. Yeah.
Okay, well,
I'm late for my planning meeting.
okay, well,